Have you ever wondered where the sun's power actually ends? Not the sunlight you see every day, but the invisible energy that stretches billions of miles into space. Right now, NASA is preparing a spacecraft called IMAP, short for Interstellar Mapping and Acceleration Probe, and its mission is simple but mind-blowing: to explore the very edge of our solar system. It's heading about 1.5 million kilometers away from Earth, to a place where the sun's influence starts to fade and the rest of the galaxy begins to take over. Imagine that for a second, beyond Pluto, beyond everything we've sent before, there's an invisible frontier, a cosmic boundary where charged particles from the sun collide with particles from deep space. Some call it the edge of the solar bubble, others call it the cosmic shield, but NASA wants to know exactly what it is and what's waiting on the other side. Because beyond that border lies interstellar space, the space between stars, a place we've never truly explored. IMAP will act like a detective, tracing how the sun's wind protects us, how cosmic rays sneak in, and maybe even how life on Earth stays shielded from dangerous radiation. Think about that. Our tiny planet, floating in a vast sea of stars, protected by a bubble of energy we can't even see. This mission isn't just about space, it's about survival. It's about finding out what keeps us safe in a galaxy that's anything but calm. So the real question is, how strong is our shield? And what happens when we finally reach the edge? Before we dive deeper, don't forget to hit that subscribe button and like the video. It really helps us bring you more amazing space stories like this one. So, what exactly is the heliosphere everyone's talking about? Think of it like an invisible bubble, a massive shield created by the sun's solar wind, constantly blowing charged particles in every direction. This bubble surrounds every planet in our solar system, including Earth, and it keeps out a lot of the dangerous radiation that comes from deep space. Without it, life as we know it probably couldn't exist. Now picture this. The sun's energy pushes outward while the pressure from interstellar space pushes back. Somewhere between these two forces, there's a boundary, a thin, mysterious region where the solar wind slows down and the interstellar gas begins to dominate. That's the edge of the heliosphere. Scientists call it the heliopause, and it's the line that separates our solar system from the rest of the galaxy. But here's the catch: we've never seen it directly. The Voyager 1 and Voyager 2 probes crossed that boundary years ago, sending back the first hints of what lies beyond. But they're so far away and their instruments are so limited that we only got a tiny glimpse. That's where IMAP comes in. It's designed to give us a full, high-resolution map of this cosmic frontier, a 3D look at how the sun's protective bubble really works. This isn't just about science fiction anymore. Understanding the heliosphere could reveal how cosmic radiation affects spacecraft, astronauts, and even the technology we use here on Earth. In other words, the heliosphere is our cosmic force field, and IMAP is the probe that's finally going to show us what it's really made of. So, what exactly is IMAP, and why is everyone at NASA so excited about it? IMAP stands for Interstellar Mapping and Acceleration Probe, and it's one of NASA's most ambitious missions yet. Scheduled to launch in 2025, this spacecraft will travel 1.5 million kilometers away from Earth to a special spot called the L1 Lagrange point, a kind of gravitational balance zone between Earth and the Sun. From there, IMAP will have a perfect, uninterrupted view of the solar wind as it flows outward into space. Imagine it like standing at the edge of a storm, watching how the wind and particles from the sun collide with the vast emptiness beyond. That's what IMAP will be doing, collecting particles, tracking their energy, and mapping how they move through the heliosphere. The main goal? To understand how the sun interacts with interstellar space, that thin border where our solar system ends and the rest of the galaxy begins. IMAP will study high-energy particles called pickup ions and energetic neutral atoms, which are formed when the solar wind slams into interstellar gas. By tracking where these particles come from and how they move, scientists can finally build a detailed picture of the heliosphere structure. But there's more. IMAP isn't just looking outward, it's also looking inward, helping us understand how space weather, things like solar flares and coronal mass ejections, affects Earth's magnetic field, our satellites, and even power grids. The data it collects could help protect astronauts on deep space missions, like those heading to Mars, from deadly cosmic radiation. In short, IMAP is like a cosmic meteorologist, observing the invisible winds that shape our solar neighborhood. And by doing so, it will answer one of humanity's biggest questions. How exactly does our solar system interact with the rest of the universe? All right, so let's break down how IMAP actually does all this. Because honestly, it's not just another telescope floating in space. It's more like a high-tech space detective. IMAP is packed with 10 scientific instruments, each designed to catch different types of space particles and radiation. Think of it like having 10 super-sensitive noses, each smelling a different kind of cosmic scent drifting through the solar wind. Some instruments will detect charged particles, others will study neutral atoms, and a few will measure the magnetic fields carried by the solar wind. Together, these tools will help scientists build a kind of 3D map, not of stars or planets, but of invisible energy patterns surrounding our solar system. Imagine being able to see the shape of the wind blowing from the sun. That's what IMAP will let us do for the first time. Here's the cool part. IMAP doesn't take normal pictures. It doesn't use cameras like Hubble. Instead, it detects how particles bounce, collide, or shift direction, translating all that into data. Then, scientists on Earth take that data and create detailed visualizations. Basically, they turn invisible physics into something we can actually see and understand. IMAP will constantly send this information back to Earth using a deep space network, powerful antennas spread around the world that can pick up signals from millions of kilometers away. And just to give you an idea of how precise this is, the instruments on board can detect individual particles that have traveled billions of kilometers through space before hitting the spacecraft. It's mind-blowing when you think about it. We're literally building a machine to feel the edges of our solar system, to trace how the sun's energy fades into the cold silence of interstellar space. And when those signals start coming in, they'll not only tell us how our solar system breathes, they might even reveal how other star systems out there protect themselves from the harsh radiation of the galaxy. Okay, so why does any of this even matter? Why spend years and millions of dollars sending a box of instruments millions of miles away from Earth? Here's the thing. IMAP isn't just about science for science's sake. It's about understanding our home in the galaxy. You see, the sun is constantly blasting out energy, a storm of charged particles called the solar wind. This wind stretches far beyond the planets, creating a kind of invisible bubble around us known as the heliosphere. That bubble is like a giant cosmic shield. It blocks or deflects dangerous radiation coming from deep space, radiation that could fry satellites, damage astronaut health, or even affect power grids on Earth. Without the heliosphere, life as we know it might not even exist here. But here's the catch. We still don't fully understand how that shield works, how strong it is, or what happens when it weakens. IMAP is designed to answer exactly those questions. By studying the boundary where the solar wind meets interstellar space, IMAP will tell us how the sun interacts with the galaxy itself. Think about that for a second. Our sun, one star among billions carving out its own protective bubble inside the Milky Way. It's like learning how our little neighborhood fits inside the giant city of the universe. And there's more. IMAP's data could help predict space weather, those powerful solar storms that can knock out satellites or cause blackouts. The more we understand how energy moves through the solar system, the better we can protect our technology and the people who rely on it. So, this isn't just about curiosity. It's also about safety, future space travel, and understanding our cosmic environment. The results from IMAP might even help us figure out how to send humans deeper into space, safely, beyond the reach of Earth's magnetic field. It's a mission that connects the dots, from the tiniest particles zipping through space to the massive systems that make life possible here on Earth. So what do scientists actually expect IMAP to discover out there in the deep cosmic sea? Well, here's the thing. IMAP isn't just taking pretty space photos. It's trying to catch invisible particles that have traveled for millions, even billions of miles. These tiny messengers, atoms, ions, and cosmic rays, carry the story of what's happening far beyond our solar system. Imagine opening your window and feeling the breeze. By studying the direction and strength of that breeze, you can tell what's going on outside. IMAP is doing the same thing, but instead of air, it's measuring the cosmic wind that flows between the stars. Scientists hope this data will reveal how the heliosphere actually breathes, how it expands and contracts as solar activity changes, and how it interacts with the harsh environment of interstellar space. They're also looking for clues about where cosmic rays come from. Some of these particles move at nearly the speed of light and could have been born in violent events like supernovas or black hole collisions. Understanding their origins could help explain how energy travels across the galaxy, and maybe even how the ingredients for life were scattered through space. And then there's the mystery no one can stop thinking about. What's outside our bubble? Beyond the heliosphere, the interstellar medium, that thin mix of gas and dust between stars, might hold secrets about the galaxy's structure and history. For decades, scientists have tried to understand what's out there. Now, IMAP might finally give us a map, a literal interstellar map, of our place in the universe. So yeah, this mission isn't just a telescope in space. It's a time machine, a compass, and a cosmic detective, all rolled into one. All right, let's talk about the future. What could IMAP actually change? If it works the way scientists hope, this mission could rewrite how we see the boundary of our solar system. We might finally understand where the sun's influence ends and where true interstellar space begins. Think about that, knowing the real edge of our cosmic neighborhood for the first time in human history. IMAP could also help us predict space weather better, those solar storms that can knock out satellites, mess with GPS, or even cause blackouts on Earth. By understanding how the heliosphere shields us, we might learn how to protect our technology, our astronauts, and maybe one day, our interplanetary travelers. But that's not all. The data IMAP collects could tell us how cosmic radiation behaves, crucial information if we ever want to send humans on long missions to Mars or beyond. Knowing what kind of radiation is out there and how the heliosphere blocks or lets it through could literally be the difference between life and death for future space explorers. And on a deeper level, it could help us answer one of humanity's oldest questions. Are we alone out there? Because by mapping the space between stars, IMAP is also helping us understand how environments form and evolve, and maybe how habitable worlds like ours come to exist. So yeah, it's not just another satellite drifting in the void. IMAP is humanity stretching its fingers just a little further into the unknown, trying to feel the shape of the universe we live in. And if that doesn't make you look up at the night sky differently tonight, I don't know what will. You know, when you think about it, every mission like IMAP isn't just about space. It's about us, about a species that refuses to stop asking questions, even when the answers are billions of miles away. We built metal eyes that stare into the unknown, just to understand who we are and where we come from. IMAP is one more heartbeat in that story. Somewhere, 350 million kilometers from Earth, a spacecraft is quietly listening to the whispers of the universe. And here we are, waiting to hear what it has to say. If that kind of curiosity moves you even a little, hit that like button, subscribe, and stay tuned, because the next discovery might change everything we thought we knew about our place in the cosmos.